Welcome to this live session for the first live session for this course, Basic Building Blocks of Microwave Engineering and Design Principles of RF and Microwave Filters and Amplifiers. Please ask your question. Those who are present, please ask your question. Those who are present, are you seeing the transcript of the course? At least the first 10 transcripts, are you seeing? Is anyone present in the live session? When we simulate a microwave structure, then how far? I do not understand the question. How far should be port? First thing is, this is not concerned with anything with this simulation and other things. You are talking of research things. This course is Basic Building Blocks of Microwave Engineering. So, do not ask this type of questions, because these questions are how far should be port, actually those absorbing boundary condition and other things that we have not discussed. and we have never talked of any simulation of any microwave circuit. So, the considerations, those are completely different there. What the basic parameter we should consider, that you have seen that we have repeatedly said that what are the basic parameters in the filter lectures you go. So, filter has a characteristic impedance, the filter has a pass band, filter has a stop band, filter has an attenuation in the stop band, filter has a phase constant in the pass band, stop band. All those things we have discussed in the filter lectures. So, you see the lectures, the whole mathematical analysis for designing a filter is there. See lecture 11 to 15 is based on, if you are designing the filter based on image impedance method, then you see lectures 11 to 15, everything has been discussed, and from 16 to 20 you see the insertion loss based technique and also how to scale up the prototypes, etc. So, all those things, so don't use jargons in the questions. Using MOM and FEM analysis, you join any research program of any good university, there you will understand what is MOM, what is FEM analysis and all those things, that thing you will understand. we do not answer to that type of jargonic questions. Method of moments and finite element method, those are numerical techniques. So, there are books, there are plenty of research papers available, there are plenty of courses. Based on that, there you see those things. There are plenty of books, how to apply MOM to electromagnetics. So, you see those things. Yes. So, the question is, when we say TMN or TMMN mode, what is the meaning of M and N? Actually, you have seen that modes, whether I have discussed about the concept of modes. Actually, modes are the minimal set of the solution of the Maxwell's equation. So, the energy can be taken by any of these modes if the structure supports that. Now, there, to classify that which mode is propagating, we use two subscripts with each type of mode, whether it is transverse electric or transverse magnetic. That Mn, actually when we solve the Maxwell's equation, there are various solutions. So, each solution gives the mode. So, Mn comes from that mathematics of that, but then when we see the field structure, we can say that the number of half wave variation in a particular dimension, that can be physically associated with M and N. Otherwise, M and N is a M and N are the two number for which they are valid. So, but physically then if we see the structure for the existing electric field or existing magnetic field, whatever the case may be. So, for that you can see that M and N represents index of a periodicity in that direction. So, for rectangular modes, these TTM modes, like M stands for the first half wave variation, number of how many half cycles are there in one of the direction, one of the transverse direction, and N stands for the other transverse direction, how many half cycle of variation are there. So, when I say that TE23, let us say, TE23, and suppose the transverse directions for this case are x and y of the Cartesian coordinate, then 2 will represent that the field structure of this TE23 mode, that will have 2 half cycle variation in the x direction and 3 half cycle variation in the y direction. So, these are the meanings. Similarly, if we have TM-Mn, so suppose TM23, so that will mean that the magnetic field will have 2 half cycle variation in the x direction and 3 half cycle variation in the y direction, where x and y are 2 perpendicular, but both transverse directions. So, otherwise it comes from mathematics that those values of M and N satisfy the Maxwell's equation. So, they are one solution. So, wave can take power in that mode also. Sir, the question is, I think it earlier question was your question, can we say M and N are field connection? No, 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 not at all. Field connection? No. No, no, not at all field connection. They are nothing to do with field connection. As I explained that they are mathematical numbers, but physically it has been seen that if you plot the variation, so they represent the field variation in the transverse direction, how many half cycle variations are there. Mode number means in the extent of that you will have so many half cycles. Suppose if I have instead of T10 mode, if I have T50 mode, that will mean that in the between or in the x direction there will be, in the whole structure there will be 5 half cycles, whereas in T10 there is only 1 half cycle in the structure. But they are nothing to get with field connection, but from the field configuration you will have to we take the clue that where we will connect the feed, if it is a case of antenna. If it is a feed of a excitation of a structure, then also we are try to make that if we have a if we want to excite an electric field, then obviously the place where the will have the minimum in the electric field, there we will try to put our probe. Similarly, if we try to put a current, then we see that how that circular nature of the magnetic, because you know magnetic field always is in a circle. So, what is the axis of that, so that if there we place a current, then the magnetic field will be sustained. So, all these clues we take from there. So, feed, where to put the feed and which type of feed, those things can come from the this understanding of the field structure of the mode. I do not know whether I have clarified. Please ask. If you are not satisfied, I can discuss more. I think I have tried to tell you what is the meaning of this. Please ask your questions. We are still waiting. What is the difference between wave velocity and phase velocity? Actually, you see that the how do we say phase velocity? That means the equiphase points, that is a locus. Now, with time that moves, and wave, what is a wave? That disturbance from the source that moves. Now, these two are generally different, because actually the phase, that means at suppose I am observing a particular point, a particular phase point. So, that point is moving with a velocity. Now, it may be that the whole wave is not moving with that velocity. So, I think mathematically you understand that the wave velocity, that is the actually the derivative of the position of the wave, whereas the phase velocity is the difference between the phase propagation, the displacement of that phase point with time, divided by time. Now, many times it may seen, and nowadays people are making materials where this wave velocity and phase velocity are completely different. Now, for a normal type of materials, the wave velocity, phase velocity is same, or normal type of waves, but there are waves possible also where the wave velocity and phase velocity may be completely different to each other, either in magnitude or in direction. And nowadays people are producing materials which are not always present in the nature. Those are called metamaterials, etc., where they are playing with this phase velocity, wave velocity. So, but one thing you will remember, that wave velocity actually is the velocity with which the energy gets transported, whereas phase velocity is actually for observing. We introduce this phase velocity concept so that we can observe the wave. So, that is why more fundamental quantity is this wave velocity, which is actually the wave which is made of a group. So, there sometimes wave velocity is also called group velocity. So, the whole wave as a whole is moving with what velocity, that is more fundamental, more important. Phase velocity is a manifestation of that. Sometimes that manifestation is correct, of the correctly depicts the movement of the energy transportation velocity, sometimes it is not, particularly with the new engineered materials. You do not get the correct thing with the phase velocity, because they always do not depict the energy propagation velocity through a particular medium. Where we use cylindrical waveguide. Actually, you see that there are various structures. Also, there are various there are various radiating structures which are easier to make with cylindrical geometries. One example I can give, that if you want to have an antenna with good polarization in all the direction, that means the electric field will be almost equal in all the directions, then instead of having a rectangular type of thing and circular antenna will be better. Now, to connect to those type of structures, also there are certain modes in the waveguide, in cylindrical waveguide, certain modes are there which gives equal field distribution, field is equal in all the directions. So, in those cases you use cylindrical waveguide. Another thing is, you see nature actually has one thing is, you have various structures which are planar, you have various structures which are cylindrical in nature. You see that suppose you are fabricating steel. Now, one structure that manufacturers of steel do is plates. Then after that you do rolling and you get a structure like cylinder. Also you can have something like sphere, etc. So, in nature also these type of various things are possible. So, our wave transportation, wave radiation, that also takes place through this type of structures. So, depending on the structure, if you have a structure which is having a circular symmetry, then I think you will have to choose whether to use cylindrical waveguide or some other waveguide which has that circular uniformity. Rectangular waveguide is not a fit case there. So, based on that thing we choose what waveguide to use at which points. So, there are also, if the structure is elliptical, then you can use elliptical waveguides. If the structure is two planes going parallel plate, then you can instead of a waveguide you can have also something like parallel plate waveguides. So, that those type of things nowadays people are researching and finding. So, actually the given structure, given radiation, given field configuration, that dictates that what you will do. In satellite communication etc., where this what I first said that circular polarization is a necessity, because they do not know that from a particular angle they are sending, but they want that everyone who are receiving the signal should get at least some portion of that, and there should not be any discrimination between the receivers of that signal. So, they prefer the circular polarization. Now, to have a circular polarized thing, they also design antennas which are easily kept inside and then kept open or they make it open in the space. So, to connect with that type of circular polarized radiators, you need definitely cylindrical waveguide. Cylindrical waveguide means in one direction it is not changing, that is its in axial direction it is having no change, but you are having a circular geometry throughout. So, if those radiators or source load they have that type of structures, then you need waveguide to connect to them. What is the mathematical modeling for Mimo antenna? Actually, you see these are all research topics, these are not in the purview of this course. So, these are nowadays the mathematical models of Mimo antennas are available. You see in IEEE transactions on antenna and propagation, lot of research papers coming. So, there I cannot discuss it in this class. Also, this is not in the purview of this course, this is a very basic course, probably you are a very advanced student. So, there you will see there are lot of journal papers etc., where Mimo antennas are there. Also, antenna I have not discussed in this class, there is another NPTEL course on antenna, but there are also Mimo antenna etc., those are very recent topics. So, there you if you are interested in research, join a research program in any good university, there you will understand all this. How antenna radiates and wave? So, actually you see again this is not part of this course, but still this is a fundamental question. Question is, you see that actually in this course we have discussed about resonators, or in your undergraduate course you have seen resonators like LC circuit, and a bit more practical of that is an RLC circuit etc., which resonator means if you have an excitation, then the resonator depending on its LC values, it chooses a particular frequency and resonates there. So, that means it suddenly the amplitude shoots up. Now, the question is, if that needs to be sent to the wireless medium or wave medium, free space medium, then you need to have an impedance matching of that resonator to the antenna, to the free space. So, antenna does that. Also, antenna has another purpose, that antenna tries to focus the energy propagation in a particular direction. So, antenna, that is why it is a distributed structure, but it every you can consider that it is a distributed source, every source is radiating, but somehow that radiation is, when you are superimposing that, you are getting a positive shooting up in one direction and cancellation in other direction, something like interference fringes that you have seen in optics. So, antenna has that thing. So, antenna will have to do these two things. One is it will have to transfer it proper impedance, so that the power is whatever in the resonator is sustaining oscillation, that oscillation can be thrown to the free space. So, for that impedance matching is necessary, antenna gives that. Another is antenna gives a directive property by proper superposition of various distributed sources. So, these two are necessary to radiate a wave meaningfully. How do we distinguish between narrowband and wideband antenna? Actually, that distinction, you see, narrowband and wideband, these are all controversial terms. Actually, generally IEEE has a, not only for antenna, actually for any electronic system, the IEEE's definition is that if the percentage bandwidth is more than 20% or 500 megahertz, which one is larger, then the system is called wideband. But there are, in electronics community, there are people who oppose to it. Even some of the American standards and European standards, they also do not adhere to this, because there are actually various modern system, particularly pulsed systems, where this bandwidth definition what IEEE does, that means the definition is bandwidth is defined as the 3 dB bandwidth. So, that divided by the center frequency. Now, in practical cases it is difficult to find those things, because always that 3 dB bandwidth, that is not there, because the thing may have a haphazard variation. Actually, for regular sinusoidal type of signals, the IEEE definition is correct, but otherwise people have, there are communities who define bandwidth in a different way. They have the, particularly the pulse people, that means those who send pulses, you know, pulse, practical pulses can have haphazard type of Fourier spectrum. So, for them they define bandwidth to be the highest acceptable part minus the lowest highest acceptable frequency FH minus FL divided by the middle portion or center frequency. So, by that definition, actually you can have bandwidth from 0 to 200%. So, depending on various bands, they have various terms: hypo band, hyper band, wide band, then meso band. So, there are various terminologies. So, it cannot be seen, but roughly you see 500 megahertz, at least 10 years back it was a huge bandwidth. So, all the systems which were having at least 500 megahertz or 20% fractional bandwidth, that we used to call wideband. But nowadays, when the systems are taking much more bandwidth, so these definitions are getting challenged, and that is why I said that these pulse people, they have made their own terminology, mesoband, hyperband, etc. So, but roughly it is dependent on what is the percentage. Narrow band means less than 5% bandwidth, that is generally called narrow band systems, provided you have the sinusoidal type of signal. The next question is, what is mutual coupling? Actually, you see, when one radiator radiates, then theoretically the whole universe gets affected. So, actually there was the one question was there, that where do we put the port in a simulator? Actually, you see, if I create a disturbance here, if there is a accelerated charge here, the whole universe gets affected. Now, obviously with the as you go further and further, the effect gets less pronounced. Now, mutual coupling means that if this effect which is going, but it is progressively getting reduced if you move in space. So, up to certain distance it will affect another radiator. So, it will affect him, it will induce a electric and magnetic field there. So, that is why it will induce a voltage and current in that radiator. So, if it is not within the acceptable limit, then it is called a mutual coupling. How we can minimize the effect of mutual coupling in case of array antenna or MIMO antenna? There are lot of literatures. Actually, I remember Robert Mello, who is one of the pioneers of mutual coupling analysis of A. He has written a book, Arctic House book on this mutual coupling in antennas, etc. So, there you see, but roughly I can say that you stop the path. So, first thing is you do not allow the thing to, because it can affect another radiator provided that radiator accepts that coupled field. So, you design that radiator in such a way that it does not accept that. Every radiator does not accept all types of field. You can cut, that is the main beauty of your waveguide learning, that there is a cutoff. So, some of the fields you can allow, some of the fields you do not allow, that is number one. Number two, in the path you put obstacles, like if they are going through a metallic path, then you cut that path, you put some obstacles. If they are going through the free space, there you can put some other dielectric to stop their or to reduce their velocities substantially, to reduce their effect substantially. So, there are lot of novel ways by which you can do that. Array antenna, MIMO antenna, those are separate topics. Do not ask questions what is your research interest, you do not try. First you learn these subjects, because this learning will give you understanding that how to do all those research type of novel things. Because if you do not understand it now, that how it propagates, how it gets coupled by these fundamental things, you will have trouble there. In any other radiating patch instead of copper, is there any other radiating patch instead of copper? Yes, you can make with silver, you can make with if you have money, you can make with gold, you can make, but best thing is you can make with silver, but silver the fabrication is difficult, that is why people try to do with gold. There are lot of, you see, even some good connectors they are made with this gold, etc. And copper is cheap. If you do not use copper, you can use aluminum also. So, any metal, first you see what is the conductivity of that metal, that conductivity will give you that how much loss, conductor loss it will take. Now, if that conductor loss you can sustain, then you can make patch with that, no problem. Why does the antenna becomes directional at high range of frequency? No, it is always directional. There is no isotropic antenna people invented. So, isotropic antenna is a concept we discuss, but actually any distributed structure that will have a directional nature. So, not at high frequency. If you design a antenna at any RF frequency, then it should have a directional characteristic. Now, how good directional nature or how good focusing you can make, that depends on your antenna design. So, there are various antennas you see that a thing, and another thing is you will have to understand how that distributed sources they are getting cancelled, or mathematically if you say basically the field at any point is a spatial Fourier transform of the aperture field distribution. So, if you know aperture field, you can find out that what type of Fourier transform will give that, or if you want a directional nature. So, from that if you inverse Fourier transform and see that whether any aperture can produce that type of electric current or magnetic current, and so those things are advanced antenna topics. I find EN waves very difficult to study, as well as the propagation in transmission lines and waveguide. Give some tips. Tips are follow the lectures. Also, I think that this difficulty comes because one thing is wave, you see that actually the non-wave things, that means circuit theory, that is does not consider space as a variable, only time is a variable there, but actual thing is a wave which is both space and time variable. So, we will have to understand the derivatives in space like divergence, curl, etc., gradient. So, please brush up those things. Also vector calculus you should be thorough to understand EM theory. So, I think you have a weakness there. Then coordinate, various coordinate systems, like particularly the cylindrical coordinate and the spherical coordinate, probably you have difficulties there. And propagation in transmission lines in waveguide, try to see, actually mathematics is heavily needed. You see, we are, that is why in this course basic building blocks we are trying to tell you the basic mathematics that is needed. So, try to follow that up. If you not come to forum and there you ask, because here in one line that or my tips giving will not give. Where exactly you are finding difficulty, you say that when we are discussing from the scratch, but if you have their difficulty, you ask in the forum, that will help you. Why damping effect? Why damping effect due to load? The sentence is not clear. How damping affect what? How damping affect what? Damping means a presence of resistance. Please recollect your LC circuit. Now, in an practically no LC circuit is possible, because there will be always an R. That R gives you damping. So, any, now forget R. So, if you have a pure LC circuit ideally, then sorry, if you give a disturbance to it, you will have a oscillation. Now, damping will make that oscillation come to a steady state. So, gradually with time the oscillation amplitude will reduce and finally, it will go to a steady state value. So, that is the role of damping. That means, it produces an exponential taper in a otherwise undamped oscillation. I think that was the question or not, I did not understand. Why do we use fractal geometry in radiator or in ground plane? As I said that actually all these are, fractal is a different thing. Actually, you need to sometimes put an obstruction to the wave. So, for that various periodic structures are put, because a fast wave can be made to slow wave by making a periodic structure. Any periodic structure will make that. Also, that will produce a pass band, stop band filter type of thing. Now, fractal is that instead of so many periodic things, if you try to shorten that by geometrical means, that is called fractal geometry. But the main way thing is, you are trying to put a periodic thing, so that a fast wave becomes a slow wave, and then you can have interaction with that wave. It is used in when the microwave things is produced, it is used in various filter applications. Nowadays, it is used to have various, that means discriminate in frequency. I will have certain frequencies to plus, I will have certain frequencies to stop. In gun diode, what is the question? Watch it, the previous question. How due to load? Again, I am not understanding. Gun diode means you will have to bias it to a negative region thing. Otherwise, it will be like a normal diode. So, that is a quantum mechanical phenomena. So, by there you tunnel through it and then the gun diode is made so that you can get a negative resistance thing. Now, always doing that actually in the there will be damping etc., those will be present, but sorry. I think these questions you should come to forum. I do not know whether you know how to access forum. There you ask, there the TAs are there, they will be able to tell you something, because in the forum we have not seen any participation. I think only when you are not getting something, either this figure is missing or this notes are missing, you are coming to forum. You means 1 or 2, but otherwise, and also please understand that these courses are undergraduate courses. So, here please do not bring your research type of thing. For that you there are, we have throughout our country, we have various IITs, we have various NITs, we have various universities, their professors are there. So, if you want to do research, you contact them, but these courses are not for that research. These courses are mainly for students who are doing undergraduate courses, okay? And basic things of that, if you want to clear that, you ask in here. Again, I am saying you that please do not ask this type of question, circular slot antenna, those jargons do not use. I have not used that. How to draw equivalent circuit of circular, that you join our PhD program, you join PhD program of any university under a good professor, he will teach you how to do that. But if you know how to draw equivalent circuit of a resonator, then you will be able to do that. If you know how to draw a circuit of a filter in your undergraduate, then you will be able to do that. Otherwise, even joining there will not solve your purpose. So, please stop asking or coming with these questions, that first you clear your thing. Anything, any radiator, its equivalent circuit can be drawn, any electrical circuit, equivalent circuit can be drawn. For that we have been taught in our undergraduate courses these type of things, that what is a resonator, what is a second order resonator, what is damping in it, all these things are basic things. So, first understand basic things. If you have, there are ample research professors, they will show you how to do that. There are in internet, there are ample research papers where from you can gather all those things. Okay. I think time is up. So, we are closing this session. So, please see the courses, see the lectures and come to the forums with the questions which you are not understanding in the lectures, we will try to answer it there.